Hey there, welcome back. So this is Ramandeep Singh, and today we're going to be solving this problem, which is find largest value in each tree row. So in this problem, we have been given the root of a binary tree, and we have to return an array of largest value in each row of the tree, zero indexed. Okay. So let's take this example. Let's understand with this example what we have to do in this problem. So in this example, we have been given a binary tree. It's like, so the binary tree is like this: 1 3 2 5 3 9, 3 2 5 3, and I think 9 is the right child. So what we have to do in this problem is, in every row we have to find the maximum value. Like here in this case, we can see that in this row the maximum value is 1, in this row the maximum value is 3, and in this row the maximum value is 9. So what do we have to return from this function is the array of these three values. Like for this particular example, we have only 3 levels, so we will return 1 3 9. And I think this order do not matter the order of these values do not matter. It has not been specifically mentioned that you have to return them in this order. So you can return these values in any order you want. So I am returning it from top to bottom. Okay. So this is the problem statement what we have to do in this problem. Now this gives a good taste of breadth first search traversal, because you can see that levels are involved here. All we have to do is to pick a level and find the maximum value on that level. So this seems like a BFS problem, like this. So just perform a BFS and find maximum value at each level. Okay. So that is one of the ways to solve this problem. But since we are solving problems using depth first search in this series, we will be using only DFS to solve this problem. Using DFS, it's easier, relatively easier, because writing DFS as compared to BFS is relatively easy. So let's see how we can do that. Now, in this case, in order to find this array, first what we have to do is to use this variable depth. So we would need this variable depth. Okay, so the depth of this node is 0. The depth of the nodes present at this level will be 1. The depth of these nodes would be 2. Okay. Now what do we have to do is to just start DFS traversal from here. So start a DFS, and I also know the depth of this node. Every node has an associated depth with it. Okay. So here this node has a depth of 0. Okay. And at zero depth I have this node 1. So I'll store this node at depth number 0. Okay. Now I move to the left child in DFS. Okay. So move to the left child, and the depth also changes. The depth increases by 1. So the depth of this node is 1, and I store this node for that particular depth as well. So 1 3. Okay. Now let's move ahead, move to the left child of this node 3. This has a depth of 2, and again store this node as well. Cool. Now I backtrack to this node and I move to the right child. Now this child also has a depth of 2. Okay. So what I am doing is I am labeling every node with the depth. So this node is labeled with the depth of 1, this node is labeled with the depth of 2, this node is also labeled with the depth of 2. Now I go to depth 2 and I already have 5, and I compare this 5 with this 3. 5 is better than 3. So I am not going to update my value at depth 5. I already have a good answer, a best answer at depth 2 so far. Now I move back to 3, move back to 1, come to the right child. So this is node number 2, this is at depth 1. So at depth 1 I already have a better answer, which is 3. So I am not going to update this 3. Now I move down, which is at depth 2, and here I have this 9. So at depth 2 the value which I already have is 5. So now I am finding a better value here in this node, which is also present at depth 2. So I can update the maximum at depth 2. So what I can do is I can update this 5 with 9. So I have 139. ठीक है, so 139 is my answer array. So all I will do is I will return this 139 from this function. So that's how I can solve this problem. So this is a strategy to solve this problem. So let's implement this helper function or DFS function in order to solve it. So let's say I have this node and then I have this depth variable, and here I see if the node is none, then I will return right from here. If it is not none, then what can be the case if this is not none? Either I am moving to the new level. So if I am moving to the new level, so let's declare an array. Let's call it answer array. So this is an empty array. So if I am moving to a new level, then I am going to add a value in this answer array simply. For instance, let's say initially when this answer do not hold any value, and node value is node has a non-none value, then I can say okay, if the depth, whatever the depth we have, is same as the length of the node, length of this answer, then in that case what I can do is, that means at whatever depth I am moving, this is the entirely new level I have arrived. So in that case I am going to store that node in that जा रहे हो कितना टाइम है? रुक जाओ फिर 5 मिनट 5 मिनट रुक जाओ 5 मिनट्स. Otherwise, if depth is not equal to length of answer, then what I can do is answer of depth. So at that particular depth I am going to update the answer which I have so far. Answer of depth with the किसके साथ, नोड की वैल्यू. रुक जाओ, चलते हैं 2 मिनट रुक जाओ, just 2 minutes. ठीक है, so that's what we have, and then we will call this call the DFS function for the left child, and then not the value, node dot left, sorry, node dot right. For the right child, call this depth plus 1. ठीक है, so in this fashion I will be implementing this function. So let's implement it. If node is none, return if this depth is same as, then what I'm answer dot append. So let's say I have this answer array as well, self dot answer. Otherwise self dot answer depth is equals to max of self dot depth comma node dot value. Call this helper self dot helper node dot right depth plus 1. Let's call this function 2 minutes. Self dot helper node 0. Let's return this array. Let's try to submit it. नोड डेप्थ सही तो है, node is not okay, not node root आएगा यहाँ पे. Got accepted. So let's submit it. So that's all for this video. I hope you learned something out of it, and I will see you soon in the next video. Till then, bye bye.